In today's class, we want to look at parametric differentiation, which is a concept in differentiation. Saka ma-concepts atakaita or atinoita in differentiation calculus, ma-concepts are there are 10, and I can just give you a quick rundown of these concepts. The first concept, differentiation of a constant. The second concept, differentiation of simple algebraic expressions. Then we go to differentiation of complex algebraic expressions, differentiation of exponential functions. Then we go to differentiation of logarithmic functions, tau-zeta differentiation of trig functions, differentiation of products, that is the product rule, differentiation of fractions, that is the quotient rule. Saka now tava pa concept number 9, parametric differentiation. From there we go to the last concept, implicit differentiation, ndo pachazoita the applicability of calculus, differential calculus. So when we talk about parametric differentiation, we are going to do a little note taking. If a curve is defined by a pair of parametric equations, so parametric equations, they work in pairs. The two equations have to be individually differentiated with respect to the parameter, and then use the chain rule to combine the two results. So what do we mean kana tichiti differentiated with respect to the parameter? Let us put this to note taking, then we explain it. Sakatati, in this case we have a curve that is defined by a pair. So in your notes I want you to underline pair. So it's defined by a pair of parametric equations. This is what we have, a curve defined by a pair of parametric equations. What happens in this situation? The two equations have to be individually, very important term again, so they have to be individually differentiated with respect to the parameter. So they have to be individually differentiated with respect to the parameter, and then use what is called the chain rule to combine the two results. Kusiyana kwakaita maths namwe ma-subject areas. Amwe ma-subject areas they are overly, overtly theoretical. But in mathematics, isho zvinikangokusiyira ipapapa. Ndatokupai na algorithm, ndo maitiro amunozviita. Then I go. Hapana zvatinge taita. Because you won't be able to mathematize those statements or put them into practice. So we are going to exemplify what we mean. Then of course we are going to have a tutorial, again with more questions on what or how we do this. And you have assignments, tests, and that is how you learn. So let us have an example. For example, in our example, we are given that a curve, right, is defined. So my curves are defined by polynomials and functions. So it's defined by the following pair of parametric equations. Icho chinombonzi parametric equations chimbori chii ungava umwe mubvunzo waminawo. Regai muone the importance and power of an example. Saka the pair of parametric equations defining this particular curve dy is equal to 2 cos 3 theta and x is equal to sine 3 theta. Saka parametric equations zvainoita isusu tajaira maequations anenge achicombine y na x. Maequations atajaira ndeaya ekuti y is equals to x plus and so forth. Kana kuti anenge akasiyana order y is equals to x squared plus minus whatever, kana kuti anenge ari cubic pamwe ari to the 4 mapolynomials akangosiyana siyana, but the key factor mumaequations atajaira anocombine both y and x, of which y ndiyo the function of x. Saka anenge aine the function of x iri defined. But maparametric equations ane a special property, anodefine x independent of y. Saka x anodefine ega omira ega uko, y odefiniwa omira ega. That is what we mean by parametric equations. X is equal to sine 3 theta, y is equals to 2 cos 3 theta. Of course, in an exam avakuudze kuti this is parametric or these are parametric equations. For the sake yekuti havasi kuda kuita hint that you should use parametric differentiation. So the moment you see x defined separate of y, then you have parametric equations. How do we do this? Saka tanyora chirungu chakawandisa apapa, but that the two equations have to be individually differentiated with respect to the parameter and then use the chain rule to combine the two results. Apa takuda kuchidemonstrata kuti chirungu chatanyora ichi chinorevei. Saka tichati y is equal to 2 cos 3 theta. We want the derivative of this. Of course, it's going to be dy d theta. Lemaka it's not dy dx. Of course, tiri kutsvaka dy dx. But apapo tati dy d theta. Because y unoyu ari kutiudza the function, the totality of the function, but theta iri kutiudza a condition inside the function. Saka pese patinoti dy dx tinenge tine situation ina y is equals to x something. Saka teta kuti dy, then dx tirikitora from x, which is the variable contained in the function y. Ameno zviri kubatika here zvati kusamotsanangura pana. Saka panapa yatiri kuwana ndi dy d theta. Saka dy d theta inenge iri equal to chi cos, that's a level, kucombine zvinhu zvakawanda. Saka apo panoshanda chi pta, power trig algebra. Do we have power? We don't. Saka we ignore power because we don't have it. Kureva kuti immediately chabva taenda kuchi kutrig. Saka panapa inenge iri 2 multiplying what is the derivative of cos. Of course ndi minus sine, then 3 theta yodzoka yakadaro. Tabva patrig tichienda pana algebra times 3. Kureva kuti eventually our answer panapa ndi minus 6 sine 3 theta. Like that. Zvinge zvatopera. Is it in any way sort of form difficult? I doubt. Okay. Then panapa, the second part of the parametric equation, dx is equal to sine 3 theta. Can you tell me what it dchi? Pause. Dx d theta is equal to x unoyo ndi anoyapa msoro, theta ari mukati umo yapa sasi, dx d theta. So what is going to be dx d theta? Pta, we don't have the power, because power inonyorwa panapa, remember. Saka tina power ndi 1. Tinayo asi ndi 1, we ignore it. As is 0 by the way, ndi 1. Okay, so we don't have the power, we go to the trig. what is the derivative of sine and cos? So it's going to be cos 3 theta multiplied by, then of course power algebra and 3 got here, it's 3 cos 3 theta like that. Saka tawana izvo manje isusu tiri kuda dy dx, but tina dy dtheta na dx dtheta. Kuti tiwane tichashandisa inonzi chain rule. Zvakaita ungwaru zvinizvi. Chain rule inoti kudini? Chain rule inoti tichatora dy dtheta tobva tati divided by dx dtheta. Mirai muone kuti zvomeka sense. Okay. Saka inoi ndo inenge tori chi chain rule. Saka ichazoshanda sei? Tinenge takuti tereresai. Tinenge takuti dy dx is equal to dy dtheta times dtheta dx. Obviously we invert kana tichi multiplier, you know. Okay. Saka panapa virtually zvakungoitika ndezvekuti dtheta uyu anochekana na dtheta uyu tosara tina dy dx. Okay. But azvo zvatichaita ndeizvi. Tichati this is equal to dy dtheta ndiani? Di minus 6 sin 3 theta times ko dtheta dx ndiani? Tarisisai kuti yatacalculate panapa ndi dx dtheta, not dtheta dx. Saka dtheta dx is just going to be 1 over dx dtheta, which is 3 cos 3 theta. Saka panoda kuva careful pakuti remember kuti hamuchatori dx dtheta, muri kuda dtheta dx, saka you have to invert this over 1 over cos 3 theta. Then from here you can easily 3 into 3 1 into minus 6 and minus 2. You're going to see with answer yenyu inenge minus 2 sin 3 theta over cos 3 theta. Kana makadzidziswa matrix munoziva kuti sin 3 theta over cos 3 theta ndi tan, so it's minus 2 tan 3 theta. Ndo inenge answer yenyu. Zvapera. Parametric differentiation yapera. Ndo chain rule yacho. Saka we are going to take y is equals to motsvaga dy dtheta, x is equals to motsvaga dx dtheta, mozoscombine ne chain rule zvowekana zvotongobuda zvapera. This is the sum of what we wanted to learn on parametric differentiation. A tutorial is coming and more questions are coming.